Hello students, welcome to this lecture 1 sequence and series NCERT exercise 8.2 questions number 25 to 32. Okay, so in our previous lectures we have discussed NCERT exercise 8.2 questions number 1 to 24. Okay, so in this lecture we are going to discuss questions number 25 to 32. Okay, so first of all, look at the first question here. Okay, so first of all, see what informations are given here. Okay, so basically we have given here 4 terms A, B, C and D. These 4 terms are in basically GP. GP means geometric progression. Okay, and then we have to show that A square plus B square plus C square multiplication B square plus C square plus D square, this is equal to AB plus BC plus CD whole square. Okay, so you have to show this. Okay, so how can you show this? So think about this. Okay, and I'm going to give you some hints to do it yourself. Okay, so here you can use the geometric progression. Okay, 4 terms you have A, B, C and D. Okay, so here you can write common ratio B over A is equal to C over B. Okay, so first equation you will get, and then use second term divided by third term divided by second term. Okay, and equal to fourth term divided by third term. Okay, and then start from AB plus BC plus CD whole square. Okay, so first of all, to try to solve this problem, you have 1 minute. Okay, so try it yourself first and then we will provide the solution. Okay, your time is over now. Okay, so now we will see the solution. So what information are given here? So we have given here basically A, B, C and D are in GP. Okay, and then we have to show that A square plus B square plus C square is multiplied that with B square plus C square plus D square. This is equal to AB plus BC plus CD whole square. Okay, so we have to show that. Okay, so let us see solution here. Answer is basically, okay, we have to show that A square plus B square plus C square multiplied with B square plus C square plus D square, this is equal to AB plus BC plus CD whole square. Okay, so let us see solution. So given A, B, C and D, okay, are in GP. Okay, so A, B, C, D forms a GP. So then we get common ratio. Okay, so if we take second term divided by first term, okay, second term divided by first term, this is equal to basically fourth term divided by third term. Okay, according to a definition of geometric progression. Okay, so second term divided by first term, this is equal to fourth term divided by third term. So here first term is A, okay, second term is B, third term is C and fourth term is D. Okay, so the common ratio B over A, this is equal to D over C. Okay, so from this equation what you will get, so here from this equation you will get BC equal to AD. How we get it? Basically we are here cross multiplied, okay, B into C, this is equal to A into D. So we also get another common ratio, okay, that is basically second term divided by first term, this is equal to basically third term over second term, okay. So common ratio second term by first term equal to third term divided by second term, okay. So from here we will get another equation, so let us see that equation. So here a common ratio B over A, this is equal to C over B, okay. So now if we cross multiply, then what you will get? So here from here you will get this equation B square equal to AC, okay. So you will get this equation B square equal to AC. Then another common ratio third term divided by second term, this is equal to fourth term divided by third term. Clear? So now from this condition you will get another equation, okay. So here a common ratio C over V, this is equal to D over C, okay. So here basically C is third term, B is second term, D is fourth term and C is third term, okay. So C over V, this is equal to D over C, okay. So now if we cross multiply, then what we will get? Then we will get C square is equal to BD, okay. So note this equation. Then what we have to prove? So it has to prove that A square plus B square plus C square multiplied with B square plus C square plus D square, this is equal to AB plus BC plus CD whole square, okay. So this is we have to prove, okay. So first we are starting with the expression AB plus BC plus CD whole square, okay. So from this expression we will start, okay. So first once substituting BC equal to AD, okay, BC equal to AD in AB plus BC plus CD whole square, what we will get? So we obtain basically AB plus BC plus CD whole square, this is equal to AB plus AD plus CD whole square, okay. Basically we substitute here BC equal to AD, okay, and BC equal to AD we get from our previous slide, okay. So BC equal to AD, if we substitute in AB plus BC plus CD whole square, then we will get AB plus AD plus CD whole square, okay. Or we can write it is now AB plus BC plus CD whole square, this is equal to basically AB plus D times A plus C, okay. Here in right hand side we common out D from AD and CD, okay. So then we can write it as AB plus D multiplied with A plus C, okay, whole square, okay. So if we expand the right hand side, okay, so if we expand right hand side expression, then what we will get? So then we obtain basically AB plus BC plus CD whole square, this is equal to A square plus A square B square plus 2ABD multiplication A plus C plus D square A plus C whole square. Basically we used here A plus B whole square formula, okay, that is A square plus 2AB plus B square, okay. Then we get here A square in A square B square plus 2ABD multiplied with A plus C plus D square multiplied with A plus C whole square, okay. Then we will get AB plus BC plus CD whole square, this is equal to A square B square plus 2A square BD plus 2ACBD plus D square times A square plus 2AC plus C square. Basically we expand here A plus C whole square, that is A square plus 2AC plus C square, okay. So now here we can substitute the value of AC and BD, okay. So once substituting, B square is AC and C square is equal to BD. Then what we will get? So then we will get basically in right hand side, we will get A square B square plus 2A square C square plus 2 times B square C square. Okay, so here we substitute AC is B square and BD is C square. Okay, then we obtain 2B square C square. Okay, this term plus D square A square. So here we multiplied each term of the bracket. Okay, we get A square. Okay, D square A square plus 2 times D square B square. Okay, here we substitute the value of AC is B square, then we get 2 times D square B square plus D square C square. Okay, or we will get AB plus BC plus CD whole square. This is equal to A square B square plus A square C square plus A square C square. Basically we have written here 2A square C square as A square C square plus A square C square. Okay, so here I've separated 2A square C square as A square C square plus A square C square. Okay, then we get A square B square plus A square C square plus A square C square. Okay, and then similarly we separate 2B square C square as B square C square plus B square C square. Okay, then we will get plus B square C square plus B square C square. Okay, and then similarly here we get D square plus A square, and then separate 2 times D square B square as D square B square plus D square B square. Okay, so then you will get this, and then last term is D square C square. Okay, so now here from first 3 terms. Okay, A square B square plus A square C square plus A square C square. Here take common A square. Okay, and then from B square from this term, okay, B square B square plus B square C square plus B square D square, take common B, and then C square B square plus C square into C square plus C square D square, take common C square. Okay, so then we obtain AB plus BC plus CD whole square. This is equal to A square multiplied with B square plus C square plus D square. Okay, plus B square multiplied with B square plus C square plus D square plus C square multiplied with B square plus C square plus D square. Okay, so basically we have taken here from 3 terms A square common, and then from next 3 terms we have taken B square common. Okay, and last 3 terms, okay, from last 3 terms we have taken here C square common. Okay, then basically we will get AB plus BC plus CD whole square. This is equal to A square multiplication with B square plus C square plus D square plus B square multiplied with B square plus C square plus D square plus C square multiplied with B square plus C square plus D square. Clear? Now taking B square plus C square D square common. Why we take common here? Because here you can see in each term here B square plus C square plus D square common. Okay, so here now taking B square plus C square plus D square common from each term, then we obtain basically AB plus BC plus CD whole square. This is equal to A square plus B square plus C square multiplied with B square plus C square plus D square. Okay, so thus A square plus B square plus C square multiplied with B square plus C square plus D square. This is equal to AB plus BC plus CD whole square. Okay, clear? Okay, now move on to next question. Okay, so here in next question, first let us see what informations are given. Okay, and then let us see what basically we have to find. Okay, so basically here in this question we have to insert 2 numbers between 3 and 81. Okay, so that the resulting sequence is GP. Okay, so we have to insert here 2 numbers between 3 and 81, and then the resulting sequence will be GP. Okay, so students, first of all try it yourself. Okay, and then we will provide the solution. So you have 40 seconds to solve this problem. Okay, and after 40 seconds we will provide the solution. Okay, your time is over now. So now we will see the solution. So first of all, see what we have given here. Okay, basically we have given two numbers, 3 and 81. And what should we have to do here? So basically we have to insert two numbers between 3 and 81. Okay, so that the resulting sequence is GP. Okay, so here are the required two numbers are basically 9 and 27. Okay, so basically we will now explain how we will get the required two numbers 9 and 27. So let us see solution now. So first of all, let G1 and G2 be two numbers between 3 and 81. Okay, so here we have to insert two numbers between 3 and 81, and here we let G1 and G2 that numbers between 3 and 81, such that the series 3, G1, G2, 81 forms a GP. Okay, so here are four terms, 3, G1, G2 and 81 will form a GP, means geometric progression. So first of all, let A be the first term. Okay, so A be the first term of the GP and R be the common ratio of the GP. So then what we will get? G1 and G2. Okay, so here G1 is second term of the GP and G2 is third term of the GP. Okay, and given here first term is 3. Okay, so then G1 is A times R, first terms into common ratio. Okay, so AR is G1 and AR square is G2. Okay, because we know general term of a GP, Gn equal to basically AR to the power n, where A is first term and R is common ratio. So using this formula, first term of a GP multiplied with fourth term of a GP, this is equal to second term of a GP multiplied with third term of a GP. Okay, so if we using this, then what we will get? Then we obtain 3 multiplied with 81. Okay, so here our first term of a GP is 3 and fourth term of a GP is 81. So 3 multiplied with 81, this is equal to second term of a GP multiplied with third term of a GP. Okay, so we here let second term of a GP is G1 and third term of a GP is G2. Okay, so then we obtain basically 3 multiplied with 81, this is equal to G1 multiplied with G2. Clear? So here given first term is 3. Okay, so here A is basically 3, and now substituting G1 is AR and G2 is AR square. Okay, in the above equation. So here here you can see in this equation G1 is AR and G2 is AR square. Okay, so substituting G1 is AR and G2 equal to R square in the above equation, then what we will get? Then we will get basically 81 equal to 3 times R cube. Okay, so from this equation we can find the value of R, that is we can find here the common ratio of the GP R. Okay, so from this equation we will get R cube is 27. Okay, so R cube is 27. From this equation what will get the value of R? So we are getting R is 3. Okay, R is 3. R is equal to 3 is basically solution for R cube is 27. Okay, so the value of R, the value of common ratio of the GP R is 3 here. So now substituting A is 3, okay, and R is 3. Okay, so we know G1 is AR, okay, and G2 is AR square. So G1 is AR and G2 is AR square. Here if you substituting A is 3 and R is 3, then you will get G1 is A times R, that is 3 times 3. Okay, and 3 times 3 is 9. Clear? And G2 is AR square. So if you substitute A is 3 and R is 3 in AR square, then you will get 3 times 3 square, that is 27. Okay, so G1 is 9 and G2 is 27. So thus the required two numbers are basically 9 and 27. So if you can check it, okay, 3, 9, 27 and 81. Basically this sequence is GP. Okay, so you can check it. So I here this is the final answers. The required two numbers are 9 and 27. Clear? So now we will move another question. So here in this question we have to find the value of n, so that a to the power n plus 1 plus b to the power n plus 1 divided by a to the power n plus b to the power n may be the geometric mean between a and b. So what we have given here? We have given here a to the power n plus 1 plus b to the power n plus 1 divided by a to the power n plus b to the power n is geometric mean between a and b. Okay, so I hope you all know that if we have two numbers and that two numbers are in GP, okay, we have to find the geometric mean of two numbers, that is basically square root of AB. Okay, so use this concept and then try it yourself. Okay, so you have 1 minute to solve this yourself, and then we will provide the solution. Okay, your time is over. So now we will see the solution of this problem. So first of all, see the question. Okay, so basically we have to find the value of n. Okay, so that a to the power n plus 1 plus b to the power n plus 1 divided by a to the power n plus b to the power n may be the geometric mean between a and b. So answer is here n equal to minus 1 by 2. That means the value of n is minus 1 by 2. So now let us see solution. So given here a to the power n plus 1 plus b to the power n plus 1 divided by a to the power n plus b to the power n is the geometric mean between a and b. Okay, so we have given this and then we have to find the value of n. So as you know that geometric mean of a and b is square root of AB. Okay, so we know that. So geometric mean of AB is basically square root of AB. Okay, so by the given condition, so we have given here a to the power n plus 1 plus b to the power n plus 1 divided by a to the power n plus b to the power n is the geometric mean between a and b. Okay, so by the given condition, a to the power n plus 1 plus b to the power n plus 1 divided by a to the power n plus b to the power n, this is equal to square root of AB. Okay, so now if we squaring both sides, then what we will get? So if we squaring both sides, then we obtain a to the power n plus 1 plus b to the power n plus 1 whole square divided by a to the power n plus b to the power n whole square. This is equal to AB. Okay, so if we squaring both sides of the above equation, then we obtain this equation a to the power n plus 1 plus b to the power n plus 1 whole square divided by a to the power n plus b to the power n whole square equal to a times b. Or if we now cross multiplied, okay, and if we expand a to the power n plus 1 plus b to the power n plus 1 whole square, okay, as a to the power n plus 1 whole square, that means a to the power 2n plus 2, okay, plus 2 times a to the power n plus 1 multiplied with b to the power n plus 1 plus b to the power n plus 1 whole square, that means b to the power 2n plus 2, okay, and this is equal to ab times a to the power 2n plus 2 times a to the power n into b to the power n plus b to the power 2n. Basically, we used here the identity a plus b whole square, that is a square plus 2ab plus b square, okay. So here what we will get a to the power 2n plus 2 plus 2 times a to the power n plus 1 times b to the power n plus 1 plus b to the power 2n plus 2. This is equal to a to the power 2n plus 1 times b plus 2 times a to the power n plus 1 times b to the power n plus 1 plus a times b to the power 2n plus 1. Basically, we multiplied ab in each terms, okay, a to the power 2n, 2 times a to the power n, b to the power n, and b to the power n, and then we get the expression in right hand side, okay. And here you can see in left hand side and right hand side 2 times a to the power n plus 1 times b to the power n plus 1 in common, okay. So that is basically same terms. So here we can cancel these two terms, okay. So now here you will get, after cancelling 2 times a to the power n plus 1 times b to the power n plus 1, you will get this equation a to the power 2n plus 2 plus b to the power 2n plus 2. This is equal to a to the power 2n plus 1 times b plus a times b to the power 2n plus 1, okay. So now a to the power 2n plus 2 minus a to the power 2n plus 1 b, okay, multiplied by b equal to a times b to the power 2n plus 1 minus b to the power 2n plus 2. So here you can see b to the power 2n plus 2 move into right hand side, and a times b to the power 2n plus 1 move in left hand side, okay. Then we get this equation a to the power 2n plus 2 minus a to the power 2n plus 1 times b equal to a times b to the power 2n plus 1 minus b to the power 2n plus 2, okay. So now taking common a to the power 2n plus 1, okay, in left hand side. So if in left hand side, if we take common a to the power 2n plus 1, okay, then what you will get, and if we take b to the power 2n plus 1 in right hand side common, then what you will get. So then you will get this equation, that is a to the power 2n plus 1 times a minus b equal to b to the power 2n plus 1 times a minus b, okay. So you will get this equation by taking common a to the power 2n plus 1 in left hand side and b to the power 2n plus 1 in right hand side, okay. So now if we here cancel a minus b, okay, here basically the two terms are same, okay. So a minus b you can cancel, and then you will get a by b whole to the power 2n plus 1. This is equal to 1, okay. And as you know, we can write a by b whole to the power 0 as 1, okay. So 1 can be written as a by b whole to the power 0, okay. So a by b whole to the power 2n plus 1, this is equal to a by b whole to the power 0, okay. So one comparing both sides, okay, if we compare both sides, here a by b to the power 2n plus 1, this is equal to a by b whole to the power 0, okay. So one comparing both sides, you will get 2n plus 1 is 0, okay. So 2n plus 1 is 0. So from here you will get the value of n is minus 1 by 2, Okay, so the value of n is -1/2, so that a to the power n plus 1 plus b to the power n plus 1 divided by a to the power n plus b to the power n may be the geometric mean between a and b. Okay, so the value of n is -1/2, and this is the final answer. So now let us see another question. Okay, so in this question here we have given the sum of two numbers is 6 times their geometric mean. Okay, so basically we have given sum of two numbers is 6 times their geometric mean. Okay, and as you know, geometric mean of two numbers, suppose we have two numbers a and b. Okay, so geometric mean of a and b is basically square root of AB. Okay, so we have given here sum of two numbers is 6 times their geometric mean. That means basically a plus b equal to 6 times square root of AB. Okay, and then we have to show that numbers are in the ratio 3 plus 2 times root 2 is to 3 minus 2 times root 2. Okay, so we have to show this 3 plus the numbers are in the ratio 3 plus 2 times root 2 is to 3 minus 2 times root 2. Okay, so students, first of all try it yourself and then see the solution. So for trying this question, you have 1 minute. Okay, and after 1 minute we will provide the solution. Okay, your time is over now. Okay, so now we will see the solution. So basically we have given in this question the sum of two numbers is 6 times their geometric mean. Okay, and then we have to show that numbers are in the ratio 3 plus 2 times root 2 is to 3 minus 2 times root 2. So answer here we have to show this. Okay, so let us see solution. So given here the sum of two numbers is 6 times their geometric mean. Okay, we have given this. So first of all we let the two numbers be a and b. Then geometric mean of a and b is what? So the geometric mean of a and b, that is gm equal to square root of ab. So now we have given in question sum of two numbers is 6 times their geometric mean. So according to the given condition, a plus b equal to 6 times square root of ab. Okay, so squaring both sides now, then what we'll obtain? So then we will obtain a plus b whole square is 36 ab. Okay, so a plus b whole square is 36 times ab. So also we know that this identity a minus b whole square, this is equal to a plus b whole square minus 4ab. Okay, we know this identity. So now put the value of a plus b whole square, that is 36 ab. Okay, so then you will get a minus b whole square, this is equal to 36 ab minus 4 times ab. Okay, and this is equal to 32 ab. Okay, and from here you will get this equation a minus b equal to square root of 32 times square root of ab. Okay, or you will you can write square root of 32 as 4 times root 2. Okay, so a minus b equal to 4 times root 2 times square root of AB. So then if we adding, okay, if we add a plus b is 6 times root AB and a minus b equal to 4 times root 2 square root of AB. Okay, then what you will get? Then we will obtain 2 times a is equal to 6 plus 4 times root 2 times square root of AB. Okay, you will get this. So what you will get? A equal to 3 times root 2 times root 2 times square root of AB. And now substituting the value of a in a plus b equal to 6 times root AB. Okay, so then we obtain b equal to basically 6 times square root of AB minus of 3 plus 2 times root 2 times square root of AB. Okay, you will get this. Or you will get b equal to 3 minus 2 times root 2 times square root of AB. Okay, so now from here you will get a by b equal to 3 plus 2 times root 2 times square root of AB divided by 3 minus 2 times root 2 times square root of AB. Okay, so here you can see square root of AB will cancel out and you will get a by b equal to 3 plus 2 times root 2 divided by 3 minus 2 times root 2. Okay, you will get this. So thus the required ratio is 3 plus 2 times root 2 is to 3 minus 2 times root 2. Okay, so the sum of if the sum of two numbers is 6 times their geometric mean, then the numbers are in the ratio 3 plus 2 times root 2 is to 3 minus 2 times root 2. Is it clear to all of you? I think it is clear to all of you. So in next question here we have given here a and g, am and gm. Okay, so if a and g be am and gm respectively between two positive numbers, okay, so then we have to prove that the number are a plus minus square root of a plus g multiplied with a minus g. Okay, so basically we have given a and g. Okay, a is am and g is gm. Okay, up to positive numbers. Oh, okay, and then we have to prove the numbers are a plus minus square root of a plus g multiplied with a minus g. Okay, so students, first of all try it yourself and then see the solution. So you have 1 minute to solve this problem and then after 1 minute we will provide the solution. Okay, your time is over now. So let us see the solution now. Okay, basically we have given here a and g are am and gm respectively between two positive numbers. Okay, and then we have to prove that the numbers are a plus minus square root of a plus g multiplied with a minus g. Okay, so let us see solution now. So it is given that a and g are am and gm. Okay, a is am and g is gm. Okay, between two positive numbers, and then we let these two numbers be a and b. Okay, so we are letting here two positive numbers a and b. So we know arithmetic mean of two numbers a and b, that is basically equal to a plus b by 2. Okay, so here a is equal to a plus b by 2 and geometric mean of A and B, that is G equal to square root of AB. Okay. So now from A equal to A plus B by 2 and G equal to square root of AB, what will get? We will obtain one cross multiplying, we obtain here A plus B equal to 2 times capital A. Okay. And 1 squaring G equal to square root of AB, we obtain AB equal to G square. Okay, clear? So now if we substituting the value of A and B from A plus B equal to 2 times capital A and AB equal to capital G square in the identity A minus B whole square equal to A plus B whole square minus 4AB. Okay, so use this identity A minus B whole square equal to A plus B whole square minus 4AB. Okay, and then substituting the value of A and B from A plus B equal to 2 times capital A and A times B equal to capital G square, then we obtain A minus B whole square. This is equal to 4 times capital A square minus 4 times capital G square. Okay, and from here you can common out 4, then you will get 4 times A square minus G square. Okay, so from here you will get A minus B whole square. This is equal to 4 times A plus G times A minus G. Okay. Okay, so now you can write A minus B as 2 times square root of A plus G times A minus G. Okay, so from equation A plus B equal to 2 times capital A and A minus B equal to 2 times square root of A plus G times A minus G, what we will obtain? We obtain 2 times small a equal to 2 times capital A plus 2 times square root of A plus G multiplied with A minus G. Okay, and from here you will get the value of small a, that is equal to capital A plus square root of capital A plus G into A minus G. Okay, and now substitute the value of A in equation A plus B equal to 2 times capital A, then we will obtain the value of B. Okay, so B equal to 2 times capital A minus of square root of A plus G into A minus G. Okay, so now you can write by simplifying it as A minus square root of A plus G into A minus G. Okay, thus the two numbers are basically A plus minus square root of A plus G into A minus G. So now move to next problem. So in next problem here, first of all see what informations are given, okay, and what we have to find out, so that we have to see first. Okay, so here in this question we have the number of bacteria in a certain culture. Okay, in a certain culture doubles every hour. If there were 30 bacteria present in the culture originally, then how many bacteria will be present at the end of second hour, fourth hour and nth hour? Okay, so we have given condition the number of bacteria in a certain culture doubles every hour. Okay, and there were 30 bacteria present in the culture originally, and then we have to find how many bacteria will be present at the end of second hour, fourth hour and nth hour. Okay, so students, first of all try it yourself and then see the solution. So you have 50 seconds to solve this problem, and then after 50 seconds we will provide the solution. Okay, your time is over now. Okay, so let us see the solution. So in this question, we have given this condition: the number of bacteria in a certain culture doubles every hour. Okay, so if there were 30 bacteria present in the culture originally, then how many bacteria will be present at the end of second hour, fourth hour, and nth hour? Okay, so answer is the number of bacteria at the end of second hour will be 120, fourth hour will be 480, and nth hour will be 30 times 2 to the power n. Okay, so let us see solution. So it is given that the number of bacteria doubles every hour. Okay, so it is given that. So therefore, the number of bacteria after every hour will form a geometric progression. Okay, with first term is 30. Okay, and common ratio R is 2. Okay, so basically the number of bacteria after every hour will be form a geometric progression with first term is 30 and common ratio R equal to 2. So therefore third term will be, so third term A3 will be A times R square. Okay, as we know, the general term of a GP GP AN equal to A times R to the power n minus 1. Okay, so now the third term A3 equal to A times R square. Okay, and here we have given first term is 30 and common ratio R is 2. Okay, so you will get the third term A3 equal to 30 times 2 square, that is 120. So therefore the number of bacteria at the end of second hour will be 120. Okay, so the number of bacteria at the end of second hour will be 120. So therefore fifth term A5 is A times R to the power 4. Okay, and here A is 30 and R is 2. Okay, so substitute the value of A is 30 and R is 2 in A5 equal to AR to the power 4. Okay, then you will get the fifth term A5 equal to 30 times 2 to the power 4, that is equal to 4 times 480. Okay, 480. So the the number of bacteria at the end of fourth hour will be 480. Okay, so therefore the number of bacteria at the end of fourth hour will be 480. And then as we know that an plus 1 equal to ar to the power n. Okay, so is here 30 and r is 2, then an plus 1 is equal to 30 times to the power n. Okay, that's the number of bacteria at the end of nth hour will be 30 times to the power n. Okay, so here are the nth hour. Okay, at the end of nth hour, the number of bacteria will be 30 times 2 to the power n. So now we will move to next problem. So in next problem here we have asked what will rupees 500 amounts to in 10 years after its deposit in a bank which pays annual interest rate of 10% compounded annually. Okay, so here we have to find what will rupees 500 amounts to in 10 years after its deposits, okay, in a bank which pays basically annual interest rate of 10% and compounded it annually. Okay, we have given this in this question. Okay, so you first of all you try this problem. Okay, so try it yourself first and then we will provide the solution. So you have 1 minute to solve this problem and then after 1 minute we will provide the solution. Okay, your time is over. So now we will see the solution. So what we have to find here? Here we have to find basically what will rupees 500 amounts to in 10 years after its deposit in a bank which pays annual interest rate of 10% compounded annually. Okay. So answer is basically 500 times 11 by 10 whole to the power 10. Okay, this is final answer. So here first of all we will see how to solve this problem. So let us see solution. So given here the principal rupees 500, okay, and duration 10 years. So here someone rupees 500 rupees deposits in a bank, okay, and for 10 years, and bank pays annual interest rate of 10% compounded annually. So here duration is 10 years and annual rate of interest is 10%. Clear? So the interest for this principal for 1 hour is what? So the interest for this principal for 1 hour is basically rupees 500 multiplied with 10 by 100. Okay, so 500 into 10 by 100, this is actually the interest for this principal for 1 year. Okay, so this is equal to 50. So the interest for this principal for 1 year is 50 rupees. So that's the principal for the second year is what? So the principal for the second year is basically principal for first year plus interest. Okay, so principal for first year plus interest is basically the principal for the second year. So principal for first year is rupees 500. Okay, and the interest for 1 year is one year basically 50. Okay, that is 500 times 10 by 100. Okay, so 500 plus 500 times 10 by 100, this is from here you can common 500. Okay, then you will get 500 times 1 plus 10 over 100. Okay, so then you will get this. So now the interest for the second year. So the interest for the second year is basically equal to rupees 500 times 1 plus 10 by 100 times 10 over 100. Okay. So the principal for the third year is what? The principal for the third year is basically 500 times 1 plus 10 by 100 plus 500 times 1 plus 10 by 100 times 10 by 100. Basically here the principal for the third year is basically the principal for principal for second year plus interest for the second year. Okay, so that is 500 times 1 plus 10 by 100 plus 500 times 1 plus 10 by 100 times 10 by 100. Okay, so if we simplify this, and then you will get it as 500 times 1 plus 10 by 100 whole square. Okay, you will get this. So continuing in this way, okay, we see that the principal for the nth year, this is equal to basically rupees 500 times 1 plus 10 by 100 full to the power n minus 1. Okay, so the principal for the nth year, this is equal to 500 times 1 plus 10 by 100 to the power n minus 1. Clear? The amount at the end of n minus 1th year, that is basically principal for the nth year. Okay, clear? So thus the amount in the account at the end of n minus 1th year, that is 500 times 1 plus 10 by 100 to the power n minus 1. Clear? And this is equal to 500 times 1 plus 10 by 100 whole to the power n minus 1 times 10 by 100. Okay, so this is equal to 500 times 11 by 10 whole to the power n. So the amount in the amount at the end of 10th year is equal to 500 times 1 plus 10 by 100 whole to the power 10. Okay, so this is equal to 500 times 11 by 10 whole to the power 10. Okay, so the 500 rupees amounts in for 10 years after its deposit in a bank, which pays annual interest rate of 10% compounded annually, it will become 500 times 11 by 10 full to the power 10. Okay, clear? See next problem. So here in next problem we have if AM and GM of roots of a quadratic equation are 8 and 5 respectively. Okay, then obtain the quadratic equation. Basically we have given here arithmetic mean and geometric mean of roots of a quadratic equation that are basically 8 and 5 respectively. Okay, and then we have to find the quadratic equation. So students, first of all, try it yourself and then see the solution. So you have 40 seconds to solve this problem, and then after 40 seconds we will provide the solution. Okay, time is over. So now we will explain the solution. So here we have given AM and GM of roots of a quadratic equation are 8 and 5 respectively. Okay, and then we have to find the quadratic equation. So here you will get the quadratic equation is x square minus 16x plus 25 equal to 0. Okay, so how we will get that we will explain now. So here given AM and GM of roots of a quadratic equation are 8 and 5. Okay, we have given this. Then we first let the roots of the quadratic equation be A and B. Okay, so A and B are two roots of the quadratic equation. So we know that arithmetic mean of two numbers. Okay, so arithmetic mean of A and B will be A plus B by 2. Okay, and geometric mean of two numbers GM equal to square root of AB. So according to the given condition, so in given condition we have given AM and GM of the roots of the quadratic equation are 8 and 5. Okay, so according to the given condition, arithmetic mean A plus B by 2 is 8. Okay, and from if we now cross multiply, then from here you will get this equation A plus B equal to 16. Okay, and then geometric mean is square root of AB. Okay, and we have given here geometric mean of roots of a quadratic equation is 5. Okay, so square root of AB is equal to 5, and if we squaring, then you will get AB equal to 25. So the quadratic equation is given by x square minus x times sum of roots plus product of roots equal to 0. Okay, so we know this is the standard equation of a quadratic equation. Okay, so here are the coefficient of x for basically sum of roots. Okay, and the constant term is basically product of roots. Okay, so x square minus x times sum of roots plus product of roots equal to 0. Okay, so here we have given here in equation A plus B equal to 16. Okay, and AB equal to 25. Okay, that means sum of roots equal to 16 here and product of roots is 25. Okay, then here you can write x square minus x times A plus B plus AB equal to 0. Okay, so we first let the roots of the quadratic equation be A and B. Okay, so A plus B is sum of roots and A times B is product of roots. Okay, then you will get the equation x square minus x times A plus B plus AB equal to 0. Okay, so now using A plus B is 16 and A times B is 25. So if you use the value of A plus B is 16 and AB equal to 25, then you will get x square minus 16x plus 25, this is equal to 0. Okay. So thus the required quadratic equation is x square minus 16x plus 25 equal to 0. Okay, this is the required quadratic equation. Clear? So I stop here this lecture, and thank you very much to all of you.